Example 4, solve the equation over the interval 0 to 2 pi and also for all solutions. The equation here is the cosine of x times the quantity cosine of x plus 2 equals 1. All right, here we're dealing with x's. We're solving over the interval 0 to 2 pi, so the angle x is measured in radians. So when you look at this equation, okay, I have a single trigonometric function, just a cosine of x, and it looks linear because I see cosine x twice, okay, both are raised to the first power, okay. However, what does your gut say to do? Okay, well, probably distribute. Okay, if you distribute on the left side, you're going to get cosine x times cosine x. That's cosine squared of x. And then as soon as you see that, you start thinking, oh, quadratic. Okay, all right, so cosine x times cosine x, that's cosine squared x, and then plus 2 times cosine of x. Okay, that has to equal 1. Okay, so yes, if we look at it now, okay, we see that it is quadratic. Okay, we have a cosine of x as our only trig term. Here it's raised to the second power, here it's raised to the first power. Okay, so it is fitting that mold of au squared plus b times u plus c is equal to 0. Okay, this is quadratic. In order to solve it, we know our options are factoring and using the quadratic formula and extracting square roots. Okay, again, this is going to be one that is not good for extracting square roots. We've already factored, so I'm going to do this one by the quadratic formula. Okay, regardless of factoring or quadratic formula, one side has to be 0 before you start. Okay, so I'm going to go ahead and move the 1 over. So I'm going to subtract 1 from both sides. That's going to give me the cosine squared of x plus 2 times the cosine of x minus 1 is equal to 0. Okay. If it helps you to convert it over to u's, go ahead and do so. It's definitely not a requirement here. If u is equal to the cosine of x, okay, we know that this statement here can be translated as cosine x times cosine x plus 2 cosine of x minus 1 equals 0. So if you let u be the cosine of x, we can rewrite this as u squared plus 2u minus 1 equals 0. Okay, that looks a little more comforting because the trig part is out. Okay, but here for the quadratic formula, you need to identify the a, b, and c. Okay, so here a is going to be 1, the number in front of u squared, or alternatively in front of cosine squared x. B is going to be the number in front of u, or the number in front of cosine x. That's going to be positive 2. C is going to be the constant, which is just negative 1. You cannot make these identifications until one side is equal to 0. Okay. All right, so these are the guys that we're going to plug into the quadratic formula. Okay, so we are trying to solve for this. Okay, actually, it probably would be best, okay, to go ahead and stick with this substitution here. Okay, so if we're trying to solve u squared plus 2u minus 1 is equal to 0, okay, the quadratic formula is going to tell us that the solutions are u is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. If we plug into this, okay, this is going to give us solutions for u, and then we can change back over to cosine of x. Okay. All right, so we're going to get negative b, so it's going to be negative 2 plus or minus the square root of b squared, so 2 squared minus 4 times a times c all over 2a. This is what it looks like if you plug it in. Okay, so if we simplify, we're going to get negative 2 plus or minus underneath the square root. We're going to get 2 squared is 4. Negative times negative is positive, so we're going to get 4 plus 4 over 2. Okay, this is going to be negative 2 plus or minus the square root of 8 over 2. Okay, If you went out to the side and you tried to break down 8, you should. 8 is 2 times 4. This breaks down into 2 times 2. So 8 is 2 times 2 times 2. So the square root of 8 is the square root of 2 times 2 times 2. You have one pair. Take out your pair of 2's, bring 1 out, and then you still have a 2 underneath. Okay, so you can check the decimal approximations here. Square root of 8 is the same thing as 2 square root of 2. Okay, so if we write that in here, this is going to be negative 2 plus or minus 2 square root of 2 over 2. Okay, we need to divide each term in the top by 2, which is the denominator. And we're going to get here that the values of u are going to be negative 1 plus or minus the square root of 2. Okay, so we need to change this back over to x's. We're solving for x's, not for u's. Okay, so in my next step, I'm going to write that the cosine of, well, I'll do it here. U is the same thing as negative 1 plus or minus this, or sorry, plus or minus the square root of 2. U is the same thing as cosine of x. Okay, so cosine of x needs to be negative 1 plus or minus the square root of 2. Okay, so what we need to do, okay, at this point, I'm leaving it as the exact value. Okay, we could look at the decimals, but I'm going to go over to the unit circle. I'm trying to find an angle whose cosine is negative 1 plus or minus the square root of 2. Okay, when I go to the unit circle, okay, cosine is associated with the x coordinate. None of these guys have such an x coordinate. Okay, what does that tell us? Okay, well, that tells us that the angle is not coming directly from the unit circle. Okay, there is an angle or angles that work. Okay, they're just not coming from the unit circle. Okay, so we're going to have to figure something else out here. Okay, all right, I am going to draw a partition in at this point so my work doesn't start running together. So give me a second here and then we will continue on. Okay, so let me just map or block this off. Okay, and we will go from there. All right, so at this point, okay, I'm going to write down what I know. Okay, I'm looking for some angle x. The cosine of x has to be equal to negative 1 plus or minus the square root of 2. Okay, this actually produces two equations. Okay, first of all, the cosine of x can be negative 1 plus the square root of 2. And then secondly, the cosine of x can be negative 1 minus the square root of 2. I just picked different signs in the middle here. Okay, all right, so we just said that the unit circle is not going to help us. Okay, so when we look at both of these equations, we're solving for x, but x is trapped by the cosine. So the only way to free it is to take the cosine inverse of both sides. Okay, so I'm going to go ahead and do that to both of these equations. Okay, so over here and then over here. Okay, you got to take whatever you do to one side, you have to do to the other. All right, so that's going to free the x on both sides. So for this first equation, I'm going to get on the left the cosine inverse of the cosine of x is equal to the cosine inverse of negative 1 plus the square root of 2. Okay, over here, I'm going to get the cosine inverse of the cosine of x is equal to the cosine inverse of negative 1 minus the square root of 2. Okay, in both of these, the cosine inverse will cancel with the cosine on the left side of the equations. Okay, so for equation 1, it's going to turn into x is equal to the cosine inverse of negative 1 plus the square root of 2. For the second equation, it's going to be x equals the cosine inverse of negative 1 minus the square root of 2. Okay, so I'm going to have to go to the calculator and punch these in. Okay, so we're going to be getting decimal answers here for our angles. They will be in radian, so when we go to the calculator, we've got to make sure that we are in radian mode. All right, so let's do it. I'm going to go to my calculator. I'm in degree mode currently, so I'm going to change over to radians. Okay, and I'm going to do the cosine inverse of negative 1 plus the square root of 2. Okay, so here we go. Let's see what that gives us. Okay, this is a radian measure. I'm going to go ahead and write out the entire decimal expansion here. So x is going to be 1.143774. Okay, and I'm using the full decimal expansion for accuracy here. Okay, so is this angle between 0 and 2 pi radians? Okay, well, remember 2 pi, what's the decimal expansion? It's 6.28. Okay, so this number 1.14 blah blah blah, it is between 0 and 2 pi radians. Okay, so that's good. And then now we need to solve for the other x value here. So we've got to do the cosine inverse of -1 minus the square root of 2. Okay, so let's see what this gives us. Oops. Let me see, did I enter that wrong? Looking at it, I have this entered correctly. So what's going on here? We're getting a domain error. Okay, so if you go back to it, if you look at this quantity that we're taking the cosine inverse of, we're taking the cosine inverse of this decimal -2.41 blah blah blah. Okay, so this number is outside the domain of inverse cosine. If you remember, what kind of numbers can we plug in to inverse cosine? You have to plug in a number between -1 and +1. So that's why we're getting the domain error here. Okay, so what does that mean? Okay, for this second equation, when you're trying to solve cosine of x is equal to -1 minus the square root of 2, there's going to be no solution from this equation. Okay, we still got a solution over here, and so that is where we're going to focus. Okay, all right, so going back to this x equals 1.14371774 radians. This is a radian measure of an angle. Its cosine is -1 plus the square root of 2. It is a solution to our original equation way up here. Okay, remember the last example that we did when we were working with these ugly decimal answers? You have to make sure that there isn't a second solution, okay? And you have to draw a sketch of a unit circle to get it, okay? So let's do that. The second equation is completely done, okay? It cannot produce a solution, but this first equation may have another value that works for x, okay? So if you remember, I went ahead and I drew my x-axis and I drew my y-axis and then I put a unit circle on it. Okay, so let me just draw this little sketchy. Okay, so here comes the circle. Okay, so here we go. And what did we find? Okay, this particular angle, okay, what it does, okay, it's a solution. Okay, it's going to give us, if you take its cosine, you're going to get this -1 plus square root of 2. Okay, I don't like working with radians very much. It's very hard to interpret. So what I can do here is, in order to draw this out, I'm going to convert it over to degrees. Okay, so I'm going to take the full decimal expansion here. Okay, I am going to multiply it. Since this is in radians, the conversion factor here is going to be 180 degrees divided by pi. Okay, this will change it over to degrees. Okay, so I'm going to go ahead and I need to bring up this decimal. Remember how we got this? Let me clear this out. We got this decimal by doing the cosine inverse of -1 plus the square root of 2. Okay, and then we're going to convert this over. So we're going to multiply by 180 over pi. Okay, so here we go. Here is the decimal measure of this angle. Okay, and this makes a lot more sense to us. Okay, so this measure is going to be 65.53019.948 degrees. Okay, so you can kind of like map this out. If I draw this particular angle, and I'll keep it color coded, this is in green. So if we drew this angle, here is the initial side of the angle. We're going to rotate counterclockwise about 65 point something degrees here, okay? So it's going to look like this, okay? This is going to be the angle. I'm going to call it x1 because presumably there will be another angle that works here, okay? It has some ordered pair on the unit circle here, okay? So it's going to be right here, okay? So this angle we know is a 65.53 and so on degrees, okay? So we know that for there to be a second solution, okay, we are looking for an angle that has the same cosine, okay? So somewhere on the unit circle between 0 and 2 pi that has the same cosine. Cosine is the x-coordinate, okay? So if I draw this angle right here, and I meant to do that in another color so we can see it, okay? If I draw this particular angle right here, okay, this angle, and I'm just eyeballing it here, okay, this sketch. Let's do it like this, okay? I'm trying to make it accurate. Okay, right here. That does not look, it's definitely not accurate. I'm just trying to make it match my drawing here. Okay, so here we go, something like this. Okay, these two guys are going to have the same x-coordinate. Okay, so imagine that these two guys line up. Okay, so that they have the same x value. Okay, so let me do this. Here's the direction that x1 went. Okay, to come up with the red angle, okay, it has to be a positive angle. So we have to start at the positive x-axis and rotate this way to get there. So this other red angle is going to have the same cosine value. Its cosine will be -1 plus the square root of 2. Okay, so we need to figure out what this angle is. Okay, well, this part of the angle right here, okay, has to match the green angle. So this thing is the 65.53 and so on degrees, okay? So the way we can get x2, which is this red angle, we need to take one revolution, which is 360 degrees, and subtract out the 65.53 and so on, okay? That's going to give us the other angle that's going to have the same cosine. Okay, so it will also be a solution to the original equation. Okay, so let's see what we get if we take 360 degrees and subtract out the other angle. You want to keep all the digits for accuracy. Okay, here it is. Okay, this is a degree measure. We will have to convert it back over to a radian measure. Okay, so let me write all of this out. So the second angle is going to be 294.4698 005, okay, degrees, and then I need to change this over to radians. Okay, so I'm going to end up multiplying it by pi over 180. Okay, so this is going to be the radian measure. Okay, so we're going to multiply this by pi over 180, and then here we go. Okay, this is the other radian measure that is going to work for us. Okay, I will go ahead and write out the whole thing. Okay, so this is going to be 5.139467 567. Okay, and this is radian, so I'm not putting a degree symbol. Okay, this decimal is less than 6.28, so it's within 2 pi. Okay, so I've got two radian measures that work, okay, for this equation. Okay, so I'm gonna go ahead and put my solutions in 2 pi. The first one, remember we need to round these guys to 4 places after the decimal point, so 1.14, let's see, that'll be 1, 2, 3, 4. Okay, so we're looking at the 1, so 7 will stay 7, so 1.1437. Okay, that is an angle in radians. The other angle that's going to work for us is going to be the 5.139, and then if we have to round this, here's the fourth decimal place. There's a 6 after it, so we need to bump it up to 5. Okay, so that's going to be the other radian measure. Okay, these are two angles between 0 and 2 pi, and they are the solutions. These are the x values that make this original equation true. Okay, so we also have to go and write down the general solution. Okay, so this will actually be pretty simple at this point. We are working with cosine here. The period of cosine is 2 pi. So we just need to take each of these solutions and add integer multiples of 2 pi. Okay, so this is going to be 1.1437 plus n times 2 pi. That's going to be the first statement. We need both statements here because if you look at your unit circle, these angles are located in different positions. Okay, the other one's going to be 5.1395 plus n times 2 pi. And again, we need to state where n is an integer. All right, so we are done. Okay, so this was another example working with a non-exact answer. Okay, so let me just kind of recap what you need to do. Okay, we solved this particular equation by the quadratic formula, okay, to get the x values that we needed. And we ended up with two different statements, okay, one right here and one right here. The second one has absolutely no solution, and so we could ignore it. The first one, if we popped it into the calculator, it produced this x value, which is an angle in radians. So that is indeed one of the solutions because that decimal is between 0 and 6.28, which is 2 pi. So we drew out a unit circle and we located the angle by converting it to degrees, so we knew what we were working with. And so then we had to draw out another angle in between 0 and 2 pi that would have the same cosine or x value. So that gave us this red angle. And so just through our drawing here, we realized we needed to take our 65-degree angle and subtract it from 360 to get this red angle. Okay, and that would give you a second solution. Okay, again, working with these decimal angles, it's difficult, okay, because you only get one solution off of the calculator, and then you have to draw it out to find the other angles that work.